In this video, we're going to graph some transformations by hand, but I want to show you some tricks of the trade that make labeling your graph a little bit easier if you understand basic principles like amplitude and period. So if we look at number one, we know the parent function is going to be sine x, but we might change the parent a little bit to take into account the fact that we're going to have a vertical stretch by 2 and a period of 2 pi over b, or 2 pi over 3. So on your handout, you'll notice that you had a basic graph labeled with pi over 2, pi over 3, 3 pi over 2, and 2 pi. And what I want you to do is kind of change it a little bit. So here, what we had to do is we had to divide by 3. So I'm going to divide all of these by 3 and let this first dash indicate pi over 6, the middle dash pi over 3, the third dash pi over 2, or 3 pi over 6, and the last one 2 pi over 3. And the reason I'm doing that is because I need my parent shape, my sine shape, to complete one full period in 2 pi over 3 on the x-axis. So I'll just label my x-axis for it to do exactly that. And then when I learn my pattern, sine starts at the origin, goes up to 1, comes back to the origin, goes down to -1, and comes back home. I can start with sine 3x with already the horizontal shrink taken into account there. So all that's left to do is to take each of those points and stretch it by a factor of 2. So 0 doesn't stretch, but pi over 6 will stretch to 2, pi over 3 doesn't stretch, but pi over 2 will stretch to -2, and 2 pi over 3 doesn't stretch. Now we could use the symmetric properties of sine to go ahead and complete this shape if we wanted. Coming down to -2, back up to -2 and back down. Notice this is now -2 pi over 3 when I've changed my axes. And this would actually be 2 periods of 2 sine 3x. Now you've all taken trig before this class, so if you know a different way to graph transformations, as long as you show your work, you're welcome to do that. But in this class, in order to get full credit, you're going to need to very clearly show these 5 points and correctly label the x-axis and the y-axis to indicate you know how to graph these transformations by hand. So you're going to need to practice that if it's been a little while. So for the second one, let's take a look and see what has to happen here. So here we have -1/2 cosine x over 2. So a couple things are happening: a reflection across the x-axis, a shrink of 1/2, a period of 2 pi divided by 1/2, which simplifies to 4 pi, and a horizontal stretch, or a horizontal stretch by 2. So notice what I did to my axis again. I just made my axis what I wanted it to be. I'm labeling this guy pi, 2 pi, 3 pi, and 4 pi just by multiplying what was already typed on there by 2. I've also chosen to label my y-axis by 1/2, and I'm going to start by graphing cosine of x over 2, because now I've done enough to know that my cosine starts at 1, comes down to 0, goes down to -1, comes back to 0, and goes up to 1. So I'm going to use this parent shape here, as my first transformation. So I started with this. Now this is not correct unless you label the x-axis, so keep that in mind when you're doing your homework. If you just draw a cosine curve but you haven't gone ahead and labeled the x-axis, then that's not correct. It's only correct if you indicate that you know that the period here is 4 pi. It took 4 pi for cosine to do this. So then we can finish taking care of the shrink by moving everything down by a factor of 1/2, or up by a factor of 1/2. Oops, sorry, don't do that. And again, this is only correct if you've labeled your y-axis. So you've labeled your y-axis to see that it's 1/2. And then of course you can use symmetric properties if you wanted to graph 2 periods of it. And you should always be connecting these with curved points. These aren't linear, right? So there's 2 periods of -1/2 cosine x over 2. So last but not least, we're going to go ahead and deal with a vertical stretch and a horizontal shift left. So what I want you to notice is I kept the axes labeled, but I included here the multiples of pi over 4. So halfway between 0 and pi over 2 is pi over 4. So just again to remind you of our counting, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4, of course just in reduced form. So I'm actually going to start with my good old parent, my basic cosine x, because I want to show both a shift and a stretch. So let's start with cosine. 1, 0, negative 1, 0, and 1. And then I'm going to go ahead and do my shift left. So I'm going to take each one of these points and shift it left a factor of pi over 4. So my point at 0, 1 comes over to negative pi over 4, 1. And that's why it's useful that I've labeled here these guys as a distance of pi over 4. It should look very similar, just shift it over. So this green graph is y equals cosine of x plus pi over 4. So to finish my graph, I just need to take this green graph here and stretch it by a factor of 3. So negative pi over 4, 1 becomes negative pi over 4, 3. Pi over 4, 0 won't stretch, but this point will come down to negative 3. 5 pi over 4 doesn't stretch, but 7 pi over 4 will become 3. So here's one period of 3 cosine x plus pi over 4. And if I wanted to, I could go ahead and just use the symmetric properties to create 2 periods if I wanted. So that would look like, let's see, down, down. And I actually would run out of space here. Finishing up, I would need negative 9 pi over 4 over here on the left to shift it left pi over 4. So whichever way you graph transformations is acceptable if you know how to label your x-axis appropriately, know how to label your y-axis appropriately, and you always show 5 points that can create the one full period of the parent function in question.